Hi, this video is about data preprocessing. In this video, we are going to discuss why data preprocessing is important and what are the steps involved. So, why we need data preprocessing? Raw data has missing information, noisy data, and inconsistent. To solve these problems before feeding it to the machine learning algorithms, we need to solve these such type of problems. So the steps for data preprocessing are data cleaning, where we are going to deal with the missing, noisy, and inconsistent data. Data integration, the problems that arise when we are using the data from the multiple sources. Data reduction, when we have a huge complex data set and the computation time is too high. Data transformation. So let's see the first step, that is the data cleaning. In data cleaning, the first point is to deal with the missing values. So first what we do, we can remove those rows which has several attributes are missing. This is not a right approach as it may lead to a loss of information. Then we can fill those missing values either by constant value or the central tendency of the attributes like a mean and a median. Or we can predict the missing values based on the other attribute values. So for this purpose, we can use the machine learning algorithms like KNN and decision tree to predict the missing values, and it works well. Then comes the noisy data. So in order to work with the noisy data, we have to explore our data and find out like what are the errors present in the data, or what are the outliers or the exceptional values. So using box plot, the clustering method, we can do so. Then comes the data integration. As mentioned, in data integration, the main problem happen because we are using the data from multiple sources. So the one conflict we can think of the data values. So suppose the attributes present in different sources are in different metrics, like suppose the weight attribute we are using in one source, it is mentioned in kilogram, and in other it is mentioned in pounds. So if we will directly feed those value into a model, it may lead to a misinformation. So either we have to change the values to kg or to pounds. Then comes the redundant data, like the age and date of birth present in the same data source. So these both attributes or columns are giving us the same information. So we should keep only one attribute, either age or date of birth. So similarly, there are a lot of attributes which are providing us the same information. So it's not a right approach to feed all the attributes to the model which are providing us the same information, as if the number of attributes are high, it may lead to a long computation problem and the many other issues. So we can detect such type of attributes by applying the correlation analysis. Then comes the data reduction. So the first is the dimension reduction. So suppose our data sets has a large number of features or the attributes. So it may be possible that all attributes are not important for our model building, or they are redundant. So how we will find out? We will apply the feature selection method and the principal component analysis to reduce our data, or we can say to reduce the dimension. Dimensionality reduction can happen this way. Then comes the numerosity reduction, where our data has a huge data volume. So in order to reduce that data volume, we chose the subset or sample of our original data that subset should represent the original data. So these are the two ways that the data reduction can happen. Then comes the data transformation. We the raw data that we receive, we directly do not feed it to our models because each attribute is different. Some are categorical, some are numerical, some data values range is different. So suppose age range lies between 0 to 100, and for salary attribute the range lies suppose between 10,000 to 1 lakh INR. So the values that are much greater, like like suppose salary has a much greater values than the age, so the salary will impact our model more than the age because its values are high, so it has a more weightage. So in order that both the attributes work equally, they both have the same weightage for in our model, we generally normalize them or rescale those attribute values. So the two methods that we use to rescale the value of attributes are the min-max normalization and the standardization. So these are the formulas how we do the min-max normalization and the standardization. In min-max normalization, we use the minimum and the maximum values of the attribute to rescale, and it gives us the value between 0 and 1. So if we apply the min max normalization on age and the salary, we will get the values between 0 and 1. So no one particular attribute is going to impact our model. In the standardization, we are using the mean and the standard deviation. So these four techniques are the basic techniques that we can follow, but this is not the end of the list. The data pre-processing steps depends upon the data. As the data varies, the problems are also different from data to data sets. So what happened? First, we explore our data and see what are the challenges, what are the problems or the issues with this data set. Then we analyze them and think, okay, how can we solve these problems? So the process of solving those issues or problems, we can say, is the data pre-processing. So like in some data sets, the values are missing, NA is present for those values. But in some data set, you will see like the question mark symbol is present wherever the values is missing. So to handle such data set is the approach is different. When there is NA, you can remove those NAs or fill the values where you will find the NA is present. For the other data set where question mark is present, your approach may be different. Or there is not only the, this is just an example, but each data set has a different and issues and the challenges that we have to handle before feeding that data to our model building. So this is just a theory and that we discussed today about the data pre-processing. In the next video, we are going to see the hands-on and using Python.